Hey everyone, this is Max Guy Channel here, and today we're going to be going through the exponential graph. So in its easiest form, sorry about that. In the easiest form, is f of x equals e to the x, where, or actually, e or a, we'll call it a for now. We'll get to e later. Well, a is a real number, real positive number, except for one. So when you think about that, if we substitute a is one, so we have one to the x. So we went through with indices, and you or just familiar with powers. So the power tells you how many times you multiply the number by itself. So one times one, one squared is one, one cubed is one. So just really why you don't really do that. You can have the whole dilemma of the one raised to the zero or the zero raised to the zero, which is undefined as you get which appears to have two different answers. So we'll just ignore that for now. But yeah, a of x. So that's usually the function. But the easiest example we're gonna use is this number called e, which we. And I hope you understand that. E is just the concept we'll be using today. So last video we talked about how, or the previous videos, it was like around 2.71 ish. Blah blah blah. So this function has a. You just take a look at it here. E of x. So you just have a look at this thing. You can see that has a horizontal asymptote. Is that y equals 0? So here. So it's kind of steeping off this direction, but it's still ending. There's a domain 0, 1, and 1e on the graph. So here's 0, 1, and 1e. Just keep in mind that whenever you're using things like a calculator, that you use on the calculator there should be a letter like that says e, like in a really fancy way. Because some calculators will have like an e, like you can treat it as a variable, and the number e is constant. So just don't get confused on that. But yeah, these 2 points will appear on the graph. The main ranges are positive because it doesn't take any negative values, as you can see. It's approaching infinity. It's approaching 0, but doesn't actually reach there. What's a one-to-one correspondence because it passes both the vertical and horizontal line test. And as I said before, this x goes towards infinity, y goes towards infinity, and when x goes towards infinity, y goes towards 0. Okay, so in the general form, f of x equals a e to the power of n bracket x minus h bracket plus k. So one of the things you should realize that when you have x as h, so the h in the power, so h minus h is 0, so n to the 0. Since e is a constant raised to the 0 is 1. So when x is h, f of x is just a plus k. You may have realized that e of x and log e of x are inverses of each other. So we search up f of x equals let's get log up for a moment. Log e of x and f of x equals x. Oh, give me a minute. What's going on here? Oh, I see. F of x equals x. There we go. See, it sort of mirrors each other here. Yeah, this is what I mean by like the inverse of e of x and log e of x. So if I should have done this earlier. Search it up, and we do f of x equals a e power of n x minus h. X minus h minus k. Okay, that's weird. Why is it not? Oh, why is the whole thing bracketing? There we go. So as per usual, a is your dilation, and because negative it flips, obviously. Let's just put this back at 1 for now. H is your left and right. K is your up and down, which changes the horizontal asymptote, and N is the other dilation in the other direction, and you can flip it. If it's negative, it flips over the y-axis. And yeah, it has a lot of this function has a lot of applications in things such as finance, population change, temperature, So financing talks about like interest loans, how especially in terms of compound interest, for the effects where things grow exponentially. Population change, so like where population is increasing or facing extinction, you have a exponential growth or decay. So the examples of E of x I can do minus. So this E of x here is called exponential growth. If I write down minus here, the exponential decay where it slowly increases. You can talk about the half-life of certain chemicals and minerals. It's lost a certain amount of time. And models like this, I mean, you can change the parameters, using with these constants, but the actual the parameters are still there. They're still the same. And yeah, that'll be all.